Welcome to this tutorial. Today we want to look at solution to non-homogeneous differential equation by variation of parameters method. Variation of parameters method is the second method on how we solve non-homogeneous differential equations. Last time we looked at our first method, which is called modification of parameters. And again, previously we looked at method of undetermined coefficients. So those are the key methods that we normally use to solve non-homogeneous differential equations. So if you did not see the previous methods, you can revisit them in the videos above. Now, welcome to this. Today, let's see how we can solve non-homogeneous differential equations by this method called variation of parameters method. Kindly remember to subscribe and also to share with your friends so that they also subscribe to this channel, so that every time we post a new tutorial, they are the first one to get the information. Okay, if you consider this differential ID here, this differential equation here of this format, this is second order differential equation, is a non-homogeneous equation. If we suppose that the solution for the homogeneous part, which is actually this left hand side, equating to 0, or letting gx to be equal to 0, then we know that if these solutions are distinct roots, then this will be the solution for the complementary equation solution, which will be c1 y1 plus c2 y2, whereby you need to know that y1 and y2 are functions of x which are linearly independent. Independence in this case, in this method of variation of parameters, is very key. So you have to know that the y1 and the y2 must be linearly independent. How do you test for linear independence of y1 or 2? We get the determinant. We compute for determinant. We arrange in this form, so we get y1 and the first derivative, y2 and the second derivative. Then we get the determinant. In short, we write that determinant like in that form, w being a function of y1 and y2. So we get the determinant of that. This this function, function of y1 and y2, we call it Roschian. We say Roschian. So it's a Roschian of y1 and y2. So that's Roschian of y1 and y2 are the one that give us the help us to know whether, or to identify whether our equation or our y1 and y2 whether are linearly independent or linearly dependent. So if you find that the Roschian is equal to 0, then you will say that y1 and y2 are linearly dependent. If we find that the Roschian of y1 and y2 are not equal to 0, then we say they are linearly independent. And our method, variation of parameters, works only for linearly independent. So they must be linearly independent. So the Roschian must not be equal to 0. You get either way, another way, you know that the method will not be viable. Now let's assume that our particular solution now is given by that v1 y1 plus v2 y2. Now we can work for v1, and we can also work for v2. so that if we get the first derivative of the particular solution, again here using the product rule, or derivative rule, product derivative rule, you'll find if you expand this is what you'll find. Remember, v is a function of x. V is function of x, so you get derivative of that. If we set then the first derivative of v1 and the y1 and the first derivative of v2 and the y2 to be equal to 0, then we see that the second derivative will be reduced to that, which should be true. Then again we get the second derivative of yp, and we are going to get that be true. Again we are applying the product rule of derivative to expand this. So then it becomes no more solving. We substitute yp, first derivative of yp and second derivative of yp, to the differential equation. Substituting to that, we will have with this kind of equation now. So that's now a transformed non-homogeneous differential equation. Substituting back respectively, we come up with equation 2, and what do we know? We know y1 and y2 are solutions to homogeneous differential equation. We know that. Why are we saying it's solution to homogeneous equation? Because y1 and y2 are solution to the complementary what? Equation, or Excel equation for our DE, homogeneous DE. That means this is true. That is true. And if that is true, even this is also true. It's also true. So here we have two equations, because they are solution to homogeneous DE. So if we have these two equations, it means that we can solve for y1. Yeah. So if you look at 2, go to 2, equation 2 here, equation 2 there, we can substitute this one to be equal to gx, and to get v1 now in this equation here, in this one here, we want to get v1 and v2. So what we need to do is first just get the first derivative of v1 and v2, first derivative of v2. Then we solve these using principles of integration. So this is equal to 0, and this is equal to that. And we have seen where we are getting this from. So that from here, rearranging the subdividing, you see that v1 is the derivative of integrand of that, and the v2 is the integrand of that. So that's generally the outline of how we come up with this. So from here you just substitute back and you get the general solution. So let's look at an example. We have this example here, which is definitely a non-homogeneous DE. We want to solve this equation by variation of parameters method. So let's solve. We get first the homogeneous part. If we solve this, using the idea of auxiliary solution to the equation, equation solution. And if you have question on this, we have done this in the previous tutorial. You can check on the link up there, and you can look at them and how we solve an homogeneous differential equations. If you have a question, leave a comment. I'll be grateful to guide you on how we solve this. So in solving this, we find that this is a repeated roots, and therefore our comprehensive solution will be given by this. So expanding, you'll find this is true. That is true. Now, remember YC, applying variation of parameters, we are introducing Y1 and Y2. So if you take the YC and you compare with the general YC using variation of parameters method, you'll find in the first case the Y1 is e power x. In the second case, Y2 is x e power x. So you can be able now to take them like this. You can cheat like this. So then yes, so our YP becomes V1 as in here, V2 x, that substituting Y1 and Y2. Then after that, we know this and this is true. So if you solve these two, solving 1 and 2 using simultaneous equations methods, the substitution or the elimination method, you'll find that this is equal to that, which implies that. Then you can see that if we have this, then we can get the integral. We can integrate both sides, and therefore we find the YP being that. So we know that the Y will be the summation of complementary plus particular solution, and therefore this becomes the answer. So if you have any question on this, you can leave a comment, and I'll be able to guide you on how you want. If you have a question, maybe assignment, you need assistant, need some guidance, I can guide you also. So kindly leave a comment. Don't forget to subscribe, and again share with your friends so that they know this particular channel, so that they may be able to revise and pass in ODE. Thank you for your time.